Sí. Okay, very good. Here we go. Okay, we are going to begin with the topic today, okay? And the topic is thermal energy and heat. So we are going to begin the class of science in the page 208, okay? So first, we are going to know about what is the relationship between heat and temperature, okay? So we should know about that first, okay? Then we are going to continue learning about what is heat and what is thermal energy. So everybody should be paying attention. And first, we are going to have a look at the picture in there, okay? So first, okay, we are going to learn the vocabulary words, okay? That in here we have the vocabulary terms that are thermal energy, heat, calorie, conduction, conductor, insulator, convention, and radiation. That is the vocabulary for this topic, okay? So we are going to complete the first paragraph that says, describe, fill in the blank with the words that you think correctly complete the following sentences, okay? When you put your hands on a cold object, like a glass of ice water, your hands become, what is the answer? Cold. Okay. The first is cold. And then the glass of water becomes warm. Okay. And then if you leave your hands on it for a long time, if you leave the glass of ice water out in the sun, the ice will start to melt. The answer is melt. Okay? Those are the words that can complete the paragraph in the page 209. Now, in the exercise number 2, okay, in the exercise number 2, we have write your own caption for this photo. In the photo, we can see that there are two people that they have the hands and the feet close to the fire camp. What can we say about that? Okay, so in there we have the answer. Okay, what is the answer? These people are warming. Why? Why are they warming? Because they are warming their hands, okay, and feet because they have the feet and the hands in front of the campfire. That's why they are warming. Because remember, at the moment that we are cold, okay, we need a sweater, okay, we need a cup, okay, or a hat or a raincoat. Then it depending of the climate, it depending of the weather, okay. So in that case we are going to have they are going to be warming. Why? Because of the campfire. Okay, remember, at the moment when you put your hands in front of the campfire, you are going to be warm. Okay, you are going to be warming. Then we have the exercise number 3. Okay, in the exercise number 3, we have many scientific words such as conductor also have everyday meanings. We are going to use this contest, okay, close to write our own definition, okay, to for the meaning. For example, the first, what can we say about what is conductor? What is conductor? Okay, so conductor, what is conductor? Okay, in the case of the school band, is very good because its conductor is a great teacher. Okay, so what can we say about that? Okay, wait, what can we say about that? So we can say that someone who directs the performance, okay, of the musical group, because in this case, remember that someone is directing or performing the the band of the school. So in that case, we are talking about that. Okay.
Mister.
Then we have, okay, then we have the second example, that is a metal spoon is a good conductor, so it will get hot if you put it into boiling soup. What will be the answer? Okay, so the answer will be that something that transfer energy. Okay, in the it will form the heat. In this case, okay, about the second answer. Okay, that is the answer about the two definitions that we can construct. Okay, remember that you are going to have the class on the platform, and you are going to see that as many times as you can. You are going to see this to write the answers on your notebook. Okay, now let's continue, because remember that we are talking about energy. Okay, what is thermal energy, what is energy, what is heat. Okay, so let's continue in the page 210. Okay, in the page 210. Okay, in this case, in the page 210, we are going to talk about what is thermal energy. What is thermal energy? Okay, what is thermal energy? Thermal energy is the total of kinetic energy of all particles in a substance. Remember that when we are talking about kinetic energy, is the energy that needs movement. Okay, the energy that needs movement. So in that case, we are talking about particles, because in all the form of our body, we have particles. So that's why we can have energy. Okay, so that is a thermal energy. Okay, in our system, thermal energy is measured in joules. Okay, remember that temperature is not energy. Okay, don't be wrong at the moment that you are talking about that, saying that temperature is the same as energy. No, no, no. Temperature is really different as energy, because energy creates movements. Okay, remember that when we have energy in our body, okay, we can move our body because of the energy that we have. But in the case of the temperature, it is not true. You can have movement when you have temperature, because it's really different. Okay, so what is the difference between thermal energy and temperature? Okay, in this case, you are going to underline the first paragraph that is saying temperature and thermal energy are really different from each other. Okay, temperature is related to the average kinetic energy of particles, while thermal energy is the total of kinetic energy of all the particles. Okay, that is the difference between these two. In that case, we have the question number 5. The question number 5, that is, what are two factors that determine the thermal energy of the substance? So let's see what is the answer in this case. Okay, the answer of the number 5 would be, okay, that temperature and total amount of particle. Okay, those are the two factors about the energy, and that about the thermal energy. Okay, so those are the two factors. Okay, the amount, the temperature, and total amount of particles. Okay, now let's continue in the page. Okay, 211. That in this case, okay, you are going to apply the concept that we have been learning. Okay, in this, we are going to circle. Okay, we are going to circle the object that has more thermal energy, the object that contains or have more thermal energy. Okay, in this case, in the exercise 1, we have a bowl of soup, a bowl of soup, okay, or pot of soup. pot of soup? The answer will be pot of soup. Pot of soup. That is the answer, okay? Though that contains more, okay, thermal energy. Now, in the second column, we have small balloon and a large balloon. Small balloon and a large balloon. What will be the answer? The answer will be the large balloon. The large balloon. Jeremy, -1. You are chatting. So in the third column, okay, we have tiger, okay, we have tiger and a house cat, and a house cat. What will be the answer? The answer will be the tiger. That tiger contains more thermal energy, more thermal energy, okay? Because remember that the tiger is all the time is in movements, okay? It's moving from one side to another side, and remember that is hunting the other animals that are close to him. Remember that he is carnivorous, okay? Now let's continue, okay? In the page 212, in the page 212, okay, we are going to continue talking about heating up. What is heat? Okay, what is heat? What is heat? Okay, in this case, okay, heat is the energy that can be transferred from one object to another object. Okay, okay, in this case, from a higher temperature from a lower temperature. For example, at the moment that we have iron, okay, for example, if you are boiling milk, for example, you put something in the stuff, you're putting something in the stuff, you're putting milk, and then you put inside of the milk, you put a spoon, okay, that spoon is going to be hotter, okay, it's going to be really hotter, okay, why? Because the milk is boiling, okay, so it's transferring the heat to the milk to the spoon, okay, that's why in that case you can transfer the spoon. So in this in the exercise number 7, if you see in there, if you see you have in here, okay, um, we have a chart. In that chart, we are going to make an arrow. We are going to draw an arrow saying from where to where the heat is transferring. Okay, from where to where the heat is transferring. And the first, we have the object number 1, that is metal rod, and the object number 2, that is fire. What will be, in which way we are going to transfer the energy? Okay, it's going to be transferred from the fire to the metal rod. So draw an arrow, dibujen la flecha in that direction from the fire to the metal rod. To the fire to the metal rod, okay, in that way. Now we have the second one. In the second one, we have the hat, okay, in the object number 1. And in the object number 2, we have a snowman and a snowman. So where to where the energy is transferred? So let's see, to the hat, to the snowman. From the hat to the snowman. In that way, the energy is transferring, okay? In the exercise number 3, we have an ice cube, okay? We have an ice cube, okay? And then we have a glass of warm water, okay? Where's to where the energy is transferring? Let's see. We are going to transfer the energy from a glass of warm to the ice cube, okay? From the glass of warm water to the ice cube. In that way, the energy is transferring, okay? Now, we have the question number 8. What is another heat exchange happening in this picture. For example, it's talking about the two girls that they are drinking coffee or chocolate. What is the reaction? What are they doing? Okay, and how can this be possible? Okay, so the answer would be energy. Okay, energy as heat is flowing from the girls. Okay, it's flowing from the girls bodies to the cold air. Okay, because they are warming, so they are transferring the energy that they have, okay, the warming, to the cold air. That's why they are warming. Okay, and then we have a what is calorie? What is calorie? What is calorie? Calorie, okay, is equal to the amount of energy needed, okay, to raise the temperature, okay. In this case, we have 1 grain of water by 1 Celsius, okay. Heat, okay, also heat can be measured in joules, okay, because heat is a form of energy, okay. Heat is a form of energy. Now, how is heat, okay, listen very carefully. How is heat related to thermal energy? How is heat related to thermal energy? Because you are adding or removing, okay, heat from a substance that will affect the temperature and thermal energy. Heat, however, is not the same as thermal energy and temperature because these are properties of the substance. In this case, heat is the energy involved when these properties can change. Okay? Remember, you need to be underlining what can you see on the presentation. Okay? So, now that we are talking about that if thermal energy is the same as heat, okay, we have the question number 8 that says, what will happen if two different objects of temperatures come into contact? What will be the answer? In this case, okay, energy as heat will be transferred from the warmer object to the cooler object. Okay, this is going to happen. Okay, the energy will transfer from the warmer object to the cooler object. In that way, it's going to be transfer the energy from one object to another one. Okay, from the warmer to the cooler. What is warmer? El más cálido. Cooler, el más frío. Okay, from one to another. Okay, and then they are going to be in the same temperature, okay, because remember that they are going to have a balance, so that they are going to have a balance in that moment. Okay, so let's continue in the page 214. Okay, in the page 214, okay, we have how can heat affect the state of an object, and this is really interesting because you need to know about this. Okay, listen very carefully. The matter that makes up a frozen juice bar is the same whether the juice bar is frozen or has melted. The matter is just in a different form. Okay, they are different forms. They are not the same. They are really different. Or state. Remember that in the last classes in the second quarter, we were talking about the states of matter. Remember that everything is different. Everything has a different mass and everything has a different volume. Okay, so the kinetic theory of matter states that the particles that make up matter moves around from different speeds. And that's true because at the moment that you are moving or that you are running, you are going to do it in a different way. For example, Jeremy is going to be speedier than me. Okay, he's going to be speediest than me. Okay, speedier than me. Él va a ser más rápido que yo. Okay, he's going to have more speed than me. Okay, in that, if we are talking in that way. Why? Because I don't like to run and I don't make exercise. But he is a young, okay, he's a student that is young and he is going to run really, really fast. Okay, that's why we are the energy in this case, the movement are in different speeds. Okay, the states of a substance, okay, depends of the speeds of the particles. Okay, adding energy to the form of heat is a substance may result in a change of state. Okay, in this case, if the particles are moving really fast, the state of the matter or the state of the object is going to be really different. Okay, so if we add more energy, may cause the bonds between particles to break. Okay, remember what is bond? What is bond? Un lazo, una unión. That is bond. Una unión o un lazo. Okay. So at the moment that we have this kind of bond, okay, is because of the particles that we have in the energy. That's why we have this kind of bond. If we add more energy, okay, the glacier, for example, the glacier may cause an ice melt into water. Okay, that is explaining at the moment that the glaciers contain more energy, so the glacier is going to melt down. So it's going to be se va a derretir. Okay, melt down. Okay, that is about that. And then we have the question number 11. Okay, in the question number 11, what are two ways to change the temp of the state? Okay, the state of a substance. Okay, the question will be the next one. When you add energy, okay, when you add energy to the form of heat or subtract energy, okay, in that way is going to be, okay, the only two ways that you are going to change this substance. Okay, when you add energy to the object in form of heat or when you subtract the energy, okay, in the form of heat. Those are the only two ways that you can use in that. Now, in the number 10, for example, what will you use at the moment that you have a hot object? For example, okay, for example, you are cooking. Okay, you are in the kitchen and you are cooking. Okay, and you have some pan. Okay, ve, some pan in there. Pan es una fridera. What would you do? Okay, maybe you are going to use a blanket, okay, or a towel, okay, because at the moment that you are going to use a blanket or a towel, blanket es una manta y towel es una toalla. At the moment that you are going to use a blanket or a towel, okay, you are not going to feel the heat in your hands. So you are not going to be hot, okay? So in that way, using that, you are not going to be you are not going to be burned. Your hands are not going to burn. Okay. Now, what is conduction? Okay. What is conduction? Conduction is the transfer of energy as heat from one substance to another through direct contact. This occurs anytime that objects are different. Okay? The temperatures come into contact with each other. Okay? They have contact to each other. That's why that is a conduction. For example, at the moment that you are touching a cable, the cable is transferring the energy from one object to another one. Okay? That's why we have energy in our house because of that energy, because of the cable that is transferring from one to another. Now, what is a conductor? Conductor is, for example, the cable that we are using at home. Okay, that is an example of conductor. Okay, what is a conductor? It's a kind of material that transfer heat very well. Okay, that transfer heat very well. We have different kind of conductor. We have gold. We have what is the other one? How do you say plata? How do you say plata? I don't remember. How do you say plata? Okay.
Silver.
Silver, thank you. Silver, okay? Silver, gold, silver, okay? That those are kind of conductors, but they are really expensive, okay? That they are really expensive. That's why we use another kind of material that they are kind of metals and they can transfer the energy from one place to another place. For example, in here in Honduras, we have energy from El Cajon. In El Cajon, so is the hydroelectric, okay? So they are making or changing the kind of the energy and they are transferring the energy with cables and we are receiving that energy to another cables and then is why we have energy in our house, okay? So that is a conductor. Okay, what is insulators? An insulator is a material that is a poor conductor of heat. Insulator, okay, they are not good at the moment that they are transferring the energy, okay? They are poor conductor of heat. Son pobres, pésimos, transfiriendo energía. So those are the insulators. Okay, then in the page in the 215, okay, we have a decide whether each object below is a conductor or insulator. In the case of the first one is a flannel shirt. A flannel shirt is conductor or insulator. Who wants to say the answer? Stephanie? No? Okay. In the case of the flannel shirt, okay, in the case of the
Is
flannel shirt, okay, is Isabella?
conductor.
Conductor.
No,
Are you pretty sure? Huh?
isolator.
Insulator, yes. In the case of the number one is insulator. Very good. What about the iron skillet? Olman, what about the iron skillet? It is insulator or what? Olman, are you there?
Conductor.
Conductor. In the case
Yes.
of iron skillet. Okay.
Yes.
Is conductor. Very good. It is conductor. Okay. What about the Cooper pipe? The Cooper pipe. Perla. Perla. It is conductor or insulator.
Um, insulator.
Insulator. No, it's conductor. Conductor. It is conductor. Okay. And what about the oven meat, Oliver? Oven meat. The oven meat is insulator or is a conductor? Oliver? Andres? Is conductor or insulator? Andres? One, two, three. Asiel, insulator or conductor?
Insulator.
Insulator. Very good. That is the answer. Yes. In the case of the oven meat, it's an insulator. Very good. Excellent. Now, let's continue in the next page. Okay. In the next page, the page 216. In the page 216, okay. In the page 216, we are going to talk about what is convection. Okay, what is convection? What is convection? Convection is the transfer of energy as heat by the movement of a liquid or gas. In most substances, as temperature increases, the density of the liquid or gas decreases. Okay? Convection occurs when a cooler, denser mass of a gas or liquid replaces a warmer, less dense mass of gas or liquid by pushing up upward. Pushing up upward. Okay? Pushing up upward. Okay, that is convection. One of these examples is when you boil water in a pot. Okay, in a pot. Okay, when you boil water in a pot, the water moves it broadly circular patterns because of that convection. Okay, it's moving. Okay, at the moment because it's boiling, and that is a good example. Okay, you can see in the picture in there, you can see the pot. Okay, that they are moving in circles at the moment that they are boiling. And then we have what is radiation. In the case of radiation is the transfer of energy by electromagnetic waves. For example, when the sun give us sunshine, that is a kind of radiation that we are perceiving or receiving at the moment. Some examples of electromagnetic waves, okay, are visible light, microwaves, and infrared light. Okay, those are examples of radiation or electromagnetic waves. Okay, and then we have a chart in the last part of the page. In that chart, we are going to complete it. Okay, we are going to make an example, or we are going to write it is conduction, convection, or radiation. In the case of the number one is when you put some food in the microwave, it gets hot. What is the answer of that? It would be radiation.
Radiation.
Yes, radiation. Okay, the answer is radiation. Now, we are going to make an example of conduction. An example of conduction is, okay, an example of conduction is a hot, okay, burner warms a cold pot. Okay, that is the answer. A hot burner warms a cold pot. That is the answer in the case of the number two. Okay, and then that is an example of conduction. And then we have a heater on the first floor of the school makes the air on the second floor warm. What will be the answer? The answer,
Convection.
huh? The answer will be convection. Yes, convection. The answer is convection. I made a mistake on the presentation. It's convection. 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 Okay? And then we have particle uses of radiation in the page 217. Okay? What are
Convention.
of radiation? What are of radiation? Jair, turn off the microphone. Okay. Two examples of radiation. What are two examples of radiation in the picture? Okay, that we have in the page 217. Okay, two examples of radiation in this. Okay, we are using the heat. Okay, we are using radiation as a heat. Listen very carefully. Okay, we are using radiation as a heat. Okay, and we are using radiation as a cooker. Okay, so we are using radiation in this case to cook. Okay, if you see the woman that is in there, the woman is cooking because of the radiation of the shine. Okay, or the sunshine. Sorry. Okay, then places the word that where solar cookers are being used. Okay. For example, we can use this kind of solar cookers in Africa, okay, or in Asia. They can use this at the moment. No sean maleducados, apaguen los micrófonos. Okay, so in Asia and Africa, they can use this kind of solar cookers because they don't have another kind of energy. Okay, and they use this kind of radiation. Okay, to make a heat, and they can make the food about this. Okay, and then how can we explain that this can work? Because of that radiation. Because of that radiation that we have, because remember that almost every year the radiation is increasing, because remember that we are cutting the forest, okay? And that's why if we don't have forest, the radiation is increasing and increasing and increasing. So at the moment that we have more radiation, we are going to have more heat, and then we are going to cook, or we are going to have more, or the environment or the atmosphere is going to be hot, hotter than all the times. Okay, so uh, what will happen if, okay, you can answer this question. What will happen if you're outside and it is a hot day? Okay, it is a hot day, and you are getting into a tree's shade. What will happen? It is a hot day. Luz,
You will feel cooler
you're feeling cooler. Uh-huh. But the question is, why? Okay, why you want to hide in the shade of a tree? Why?
because it's really hot and it burns our skin.
Uh-huh. And what is in the environment? What is in the environment? Because it's a hot
Ra-
day.
Radiation,
Aha, exactly. That is the answer. We are going to hide inside of the shade of the tree because of the radiation. Okay, and that is the answer. Okay, so that is a good answer. Okay, so thanks. Now, does anyone have a question?
no.
No. No.